Hello everyone, welcome to MES e-learning channel. In this video, we will see another problem on parallel force system. So, here we have a problem, find the resultant of the force system and also find the equivalent force and couple at point A. So, we have to find out the resultant or else equivalent force and a couple at point A of the same force system. So, on the right hand side we have given the diagram. So, first of all, in the parallel force system we have to find out resultant. So, the resultant formula is R equal to summation of all the forces. So, R will be equal to, if you see the diagram, so we have 6 forces. So, the summation of all the forces. So, this 70 Newton is acting downward. So, if the force is acting downward, it is negative. So, negative of 70. And the second force, that is 100 Newton, is acting upward. So, positive 100. And 50 Newton, the third one, it's acting upward. So, positive 50. And 86 Newton is acting downward. So, negative 86. And 34 is also acting downward. So, negative 34. And the last force, that is 90 Newton, is acting upward, that is so positive. So if we calculate, so we will get R will be equal to 50 Newton. So which is a positive, so the resultant is acting upward direction. Now we have to find out resultant. We have already found out resultant. Now we have to find out the force and the couple, equivalent force and the couple for the same given system. Now the couple, to find out the couples, we can take the moment about point A. So we can take moment about point A. Taking moment about point A. So summation of moment about point A. So it will become suffix A. So now look at the diagram now. So we have, so we have to take moment about point A. So moment about point A. So we have 6 forces. So this Newton, 70 Newton will act like this, anti-clockwise direction about the point A. So we have the force and into the perpendicular distance. So this force is acting vertical, the perpendicular distance will be horizontal one. So if you see the horizontal distance, that is 1.5 plus 2, that is 3.5. So D is equal to 3.5. So we can use the, we can frame the equation as 70, since it is a anti-clockwise direction, we will take it as a positive. So positive 70 into 3.5 distance. Now second thing, so this 100 Newton, this 100 Newton is also making an clockwise direction about point A. So the distance is now only 2 meter, because from the force the distance about the point A is 2 meter. So it is acting clockwise direction, so it is negative. So minus 100 into 2 100 into 2 meter. Now we can go with the third one. Since this 50 Newton is acting on the same point A, so there is no distance, it will become 0. Now we will go to the 86 Newton. So about the point A, it is acting again a clockwise direction and the distance is 3 meter. So it will become minus 86 into 3 meter. Now this 34 Newton acting clockwise direction, but the distance is 3 plus 1.5. So because we have to take from the force to the point, so it is 3 plus 1.5, it is 4.5. So 34 minus 34 into 4.5 meter. And the last force, that is 90 Newton. So about the point A, it is acting anti-clockwise direction. So the distance is 3 plus 2 plus 1.5, that is 6.5. So we can take as a positive, so writing downward, so 90 into 6.5. So this is our equation. If you put it in the calculator, we'll get summation of moment about point A is equal to 219 Newton meter. So again it is a positive, so it will be anti-clockwise direction. So we have to find out the equivalent and couple at point A. Since we found out this movement at the point A, so we can redraw the equation as, we can redraw the diagram as like this. So since our A is at this point A, so on the point A we have a resultant, that is 50 Newton, and at the equivalent, so we have the same movement, we found out the movement as 219 Newton meter, which is a couple. This is point O and this is point A. I hope you understood this equation, guys. Thank you for watching.